Hey there, this is Blind Man Bert, and this is another episode of the ever more infrequent aperiodic astronomical series called Astronomizoom, where oftentimes we simulate cool things coming up. Well, the whole month of January 2025 is a cool month. Um, I wouldn't say there's a lot happening in the sky overall. There's one, two, three, four, five. Well, there's three events happening on specific days, but then all month there's a couple of important things to know. Well, I think important. Useful if you're in the habit of looking up. And I'm having trouble getting my mic. I'm actually pushing stuff over to get the mic a little more aligned. Pardon me for not doing that beforehand. I hate second takes, and this is already a third take. So, let me switch gears a little bit and talk about what is not happening because I've already noticed a lot of misinformation, bad science memes about what's happening. Here's what's definitely not happening. There's not going to be a conjunction of four planets. That's a misunderstanding of what's happening. And let me explain what a conjunction is. Usually you talk about like a 2-degree conjunction. I don't even get excited by conjunctions because they happen all the time. But a conjunction is when two planets get roughly within 2 degrees, maybe 5 degrees of each other, loosely speaking. And that's the width of your two fingers held out at arm's distance. That's 2 degrees. So that's pretty close, two different planets that close. But then they have to be planets that you can actually see. So you don't want to get excited about having Neptune in conjunction with Venus, because even though Venus is very bright, you can't see Neptune or Pluto, which is not even a planet anyway, Neptune with the naked eye. And Uranus similarly. There's a few people on the planet I've heard that can barely make out Uranus. Like they can spot, oh, it's right over there, and then you check a chart and oh yeah, it's over there. But that's like 1 in 10,000 people maybe can see that well at night, and certainly not me. So we have to keep in mind there's five visible planets, six if you count the Earth, although I pointed out that in much of the Northeast you can't see the Earth because there's snow on the ground right now, which I think is a pretty good joke. So from the Earth, there are five visible planets. Now, the fake news, the bad news, the misinformation is that there will be a conjunction of four planets. There won't be. I'm looking at a NASA summary of this month. I tried to get a Celestron summary. They're a little bit more user friendly and so on, but this is a good write up by NASA. The two conjunctions that will be occurring. One is coming up in a couple of days on January 13th. It's coming up on the 12th now, so it's tomorrow. January 13th, the moon will occult Mars. What that means is the moon will be in conjunction with Mars. The moon you can think of as like a social butterfly. Once a month, it's visiting everybody on the ecliptic, and everybody is on the ecliptic. So it's visiting roughly where all the planets are. And occasionally it gets so close to something like the sun. When I say close, I don't mean like near and far, like it's going to ram into the sun. I mean, from your viewpoint, it's going to be at the same location as the sun, and that's what we call a solar eclipse. But the moon is actually tilted at enough of an angle by 5 degrees that usually it's coming in high or low, way higher or lower of the ecliptic plane, the plane that all the planets and the sun align on, more or less. And Pluto, not a planet again, but Pluto is unusual in that it's way misaligned with the ecliptic for whatever historical reasons. So the moon, it will be occulting Mars on the night of January 13th. And what that means is the moon for a while will be in conjunction with Mars, but then will actually pass in front of Mars. So for about the length of a lunar eclipse, which I'm guessing is about a half an hour, 40 minutes in that ballpark, less than an hour, for about that much time as a lunar eclipse takes, you'll see you'll see Mars disappear. And it's not really a kind of thing. Mars is actually, that's another bit of news. Mars is going to be particularly bright all month because it's in opposition, but that's another story. We're going to get to that in a second. talk about what opposition is. That means closest, brightest, basically. So near the anti-helium, to use a technical term, near the shadow of the Earth from the sun. So opposite the sun. The moon, the Mars is going to be very near that shadow, which means Mars is going to be fully bright and close, because that only occurs when the Earth and Mars being inner planets, being Mars being the first outer planet. It happens with all the outer planets. They can be in opposition, meaning closest and brightest to Earth. I mixed up my inner and my outer. You have to maybe get a bunch of marbles and line up the marbles on a piece of paper, and we'll see what I mean. Mars is outside of the Earth's orbit. Earth is here. Here's the sun. So we are closest when Mars is near the shadow of the sun or opposite the sun, if that makes geometric sense. Now, yeah, Mars at opposition, that's happening all month, but especially near the beginning of the month. So it's gradually heading away. It is in opposition, broadly speaking. There is no like boundary. Now it's in opposition, now it's not. It just means it's going to be close and bright pretty much all month. The other thing happening all month is you will have four planets visible at all times after sunset. Well, not at all times, but after sunset, you will be able to see four planets. There are some misinformation-y memes I've already seen where they're saying there's gonna be this amazing, hardly ever occurring six planets visible in the sky, and they're in a line. It's kind of clickbait. First of all, the planets are always on the ecliptic plane. The ecliptic plane can be thought of as a line that the planets are. So all the planets are always on a line, no matter what, including the Earth. We're all on the same plane, plus or minus a little bit in the case of the Moon and Pluto, for example. But it's not the alignment that's important. It's simply that all the planets are kind of on one side of the Earth. This happens periodically. It's not that rare. We had something similar about 2 years ago. I called it the string of pearls phenomenon, where right before the sun would rise, you would see a string of planets rising, followed by Mercury last, right before the sun rose. And I believe there was four visible planets at that point too, plus Uranus or Neptune thrown in there for benefit. But the term planets visible is not correct because you can't see Uranus and Neptune. So at best, you're going to be able to see with the unaided eye four planets. But it's happening every night. You'll see four planets. Specifically, right after sunset in the southwestern skies. Southwestern, right? Yeah, southwestern skies, you'll see Saturn and Venus very close together. Initially, it'll be Venus closer to the horizon, followed by Saturn, but then those two are going to go into conjunction and switch places. The conjunction will occur on January 17th and 18th. It's spread over a long time. It's not like a half-hour thing. So over a couple of days, this is really where I should be switching to Stellarium to show you this, but we're going to get there. So basically, Saturn and Venus are going to be very close together, with Venus setting first, followed by Saturn, and then they're going to switch with Saturn setting first, followed by Venus. Then if they're in the southwestern sky and you look straight up, you'll see Jupiter, which will be pretty bright and just pale yellowish color. Not particularly bright at this point because it's not close to opposition. Followed by Mars, which will be very clearly ruddish. Very few stars are this red. So it'll be ruddish, kind of reddish, and bright, unusually bright, but not super bright like the moon. Now, the moon, like I say, is going to be doing its thing going through all these planets. So in the animation, we'll see this. So I talked about the January 13th moon occulting Mars, which lasts about a half hour, January 17th to 18th. And this is visible worldwide, but the video I'm going to show is Preskit centric. So you can think of it as unfortunately, the capture isn't at 13 and a half frames per second, which is what the software can deliver. It's like only two or three. Maybe it's better because I made the window smaller at this point. It's not doing huge grabs. We'll see. We'll see what the frame rate is. But you can think of each frame as being a sky chart. We're going to do the whole month, And if you pause the video at any point, you can lie on your back with the sky chart in front of you. That's what your sky is going to be right at that moment. So I mentioned January 13th, moon occults Mars. January 17th to 18th, Venus and Saturn conjunction is occurring. That's two planets. That's all you get. The other occultation or conjunction involves the moon and Mars, and that's on a totally different day. So at no point do you get four planets in conjunction at the same time. That would be amazing. I'll talk about an epic conjunction that occurred, but we'll do that during the video because I'm going to need to fill it anyway. And then finally, all month Mars at opposition. I mentioned that. And also, this is past, but the January 3rd quadrantid meteor, quadrantid meteor shower peaked. And I'll read about that as we do the simulation. Let's get off of me and onto the simulation, which is the important part. So you should now be seeing a window, and I don't know how the change in video format will work when I cut this all together because those are two pieces of video with totally different sizes. But what we're seeing here is my little sky chart created in Stellarium software, Stellarium 23.3, available for Linux, Mac, or Windows at stellarium.org. Um, and Let me explain this. There's obviously two lines, one which is kind of curvy or archy, called the ecliptic, and the other is this green line, which is the more important one, actually. So the ecliptic plane is quite literally the plane that all the planets always align to or are close to. So in this particular case, we have Uranus here, but you can't really see where Uranus is because it's invisible. And we have Jupiter here, and we have Mars here. We have the anti-helium point there, which I'm highlighting because I want you to see that Mars is at opposition when it's close to that shadow. Again, think the sun is kind of behind us at this point. And then we have nothing else planet-wise. So right now we're just seeing Uranus, Jupiter, Mars, that's right. All the other planets are over here or coming up over here, and we'll see those when we start to animate. Now, a couple of tips. Down here, we have the real-time clock, but it's small enough that I'm going to put up another clock right here, and that's going to show the date and time. Well, that's unfortunate that it's that large, but you get the idea. This will show just the date, so you'll see where. So right now, our simulation is we're in. Oh, and it reset. I don't know why the software always does this. It resets me into Chino Valley, and I really don't want to be in Chino Valley at 0 meters because I'd be way underground. I want to be in Prescott, Arizona. Let me just reset that. Boom. Now I should be in Prescott, Arizona at a healthy 5,500 feet or so. Not up in the air. We're not a cloud city quite yet, although many of us have our heads in the clouds. We are 5,500 feet above sea level, which is pretty cool. Closer to the sky, that's for sure. Yeah, I didn't mean to touch my scroll wheel, pardon me. And I may zoom in or out a bit at times because honestly, Neptune, when you zoom out like this, will not appear. So we kind of want to know where Neptune is, even though we won't be able to see it. This is real time. So this is ticking off at 1 second real time to 1 second simulated time, but we're going to speed it up. This is New Year's Eve at 2:47 a.m. So the early morning of New Year's Eve, and we're going to speed things up. First, just a little bit, and then a lot. That's actually the a lot. So let me just back off. So what we're going to see as we run this is the ecliptic is going to move everything, as you might imagine, from the southeast, where things rise, into the northwest. So let's go slowly through part of a day slowly before we go at full tilt. The full tilt speed, I don't know what it is like simulated time to real time, but an hour will pass in like a minute. So maybe it's like 60 times faster than real time or whatever. In about 50 minutes, we're going to run off the whole month, and I'm going to narrate only part of the month because it's become very boring. When you see stuff like this, that was a satellite flying by. When we go to the proper rate, it's those things will go by so quickly that we won't even talk about them. But you can always, if you see a bright one like that one, you can always stop the video, find out the day and time, and then go online and find out what that was. So we're coming up on a time on, this is already in the past, but I just want to talk about the sequence of events. We see Mercury now getting close to the horizon. Oh, I forgot to mention, this is the horizon. So we have our compass headings. You have to imagine you're sitting on your back looking straight up. Your zenith, your straight up, is right in the middle of this. In fact, I should have marked it. Mercury is now rising. And everything outside of the circle you can't actually see because it's blocked by the ground. So the sun is below the horizon by a significant amount, by about 15, 20 degrees, and is getting close to rising. The only reason I like to have the horizon turned off is I get an early warning and I can see what's coming up. So now the sun's about to rise. So this would be the best time to see Mercury. Look at all those satellites. This would be the best time to see Mercury. And here's the radix of that Quadrantid meteor shower. It's right up here. So this is where those meteors were coming from when it peaked on January 3rd. And I'll read about what NASA says about the Quadrantids in a second. Although it's in the past, because I'm producing this on the morning of the 12th. So already like a third of the way into the month, more than a third of the way. Now it's sunrise. Guess what? You can't see Mercury anymore. Best time to see it is right before the sun rises with binoculars. Make sure the binoculars are pointed at Mercury. Make sure you're not looking into the binoculars towards the sun when the sun is up in the sky. Now it gets boring because the sun makes all planet viewing impossible except for maybe Venus and sometimes Jupiter when it's super bright. So let's go faster. We'll go to our proper rate. Every day of the month, the order will be Mercury will rise first, followed by the Sun. Then you will have Venus and Saturn, or after they switch on the 17th and 18th, Saturn, then Venus. Venus is the faster moving one, which is why it's going to go to the other side. It's moving to the outside of Saturn, if you can visualize that. So this is going a little slowly now for my taste, and we need to pick it up anyway. So now we see every day of the month, we'll see Mercury rise first, then the Sun, then Venus, then Saturn. Then we have to wait a little while. Neptune is in here somewhere. I'd have to zoom in to spot it. At this zoom out, we won't see it. Then we have Uranus rising. Now that's rising from the east-northeast. Then Jupiter rising. Jupiter's going to be pretty bright, but you won't see any of these until the sun sets. So right after sunset, look for, what's this? That's the moon, right? Yeah, that's the moon. Look for right after sunset, Venus followed by Saturn, followed by Jupiter, followed by Mars. Those are your four planets that you'll get. Forget the memes that say you're going to see six. You need a telescope, a big one to see Neptune. You need a telescope to see Uranus. You need a big telescope to see Neptune. And you need an amazingly big telescope to have a chance of catching Pluto. So basically, during the course of the evening, shortly after sunset, you'll see those four planets visible every night this month, plus the two that are invisible. Now it's January 1st. We did the boot drop. Mercury's rising. Now the sun's rising. That would have been the optimum time to see Mercury, right before the sun rose. Here's the moon coming up. You can see the moon is traveling slowly towards Venus. So it's going to become in a near, but it's also below the ecliptic by a lot. So it's come near Venus, but it's not going to get so close to Venus to call it a real 2 degree. It might come within 5 degrees, but it probably won't be. That's like 5 fingers. It won't come within 2 degrees, 2 fingers of hitting. And there's Saturn. So now we're hitting towards right after sunset every day of the week. Watch for Venus, Saturn, Jupiter, and Mars is just rising. So right there, there's your four planets: Venus, Saturn, and we're just going to keep it going at this rate from now on, which is really hard to keep up with. So this is January 1st. Every day is going to be pretty similar. Okay. It's just different parts of the sky where these things occur. You'll see the moon is the fast moving one, but we will actually be able to detect Mars moving and Venus moving because it's the one that's It's really Venus making the moves on Jupiter, and not the other way around. Jupiter's far slower moving. It's the next day. Look, we're up to the second already. Mercury rises. The daytime is the less interesting time. So I'll get in a rhythm of talking about things in between the nighttime things. See how the moon is coming up. The this is the this is the day before the peak of the quadranids. There's no simulation of the meteor shower itself, but I will read what NASA writes about it. This is a or when it occurred. This is a moderate shower, usually delivering 20 to 30 meteors per hour under clear, dark skies at its peak. No interference from the moon makes this year's peak a better bet for meteor watching. Now we just crossed into the night of the third. We get the same four planets. The moon is now still approaching here, and it's going to be the same thing. Uranus is near Jupiter, but you won't be able to see it. Neptune is somewhere over here, closer to Saturn, and I don't know exactly where, but I would have to zoom in to make that label pop up. But it's not going to be visible. Just knowing it's there is pretty cool because it is rare. Mercury is the one planet that's on the wrong side. Mercury is on the other side of the sun, but it goes around once every 88 days. So at the end of February, Mercury is going to swing around to this side of the sun. And I think at that point, there will be points in time where you'll be able to see five visible planets, but probably not for the entire month because at some point one of them is going to, you know, to get them all to hit within this horizon is the real trick. So this is the third. This is the day in the past when the Quadrantids meteor shower was peaking. The next major event we're going to have that we're going to watch for in this simulation, and again, you can pause it at any point to match whatever day and time you want. This is Prescott centric. Now that I got out of Chino Valley, and you can just stop it at any point and use that as a guide to looking up and figuring out where everything is. It should be pretty obvious because Venus is pretty bright, Mars is pretty bright and reddish, Jupiter is pretty bright and kind of pale yellow. And what's the other planet I'm missing? Saturn. Saturn is a little bit dimmer, but you're going to know it's very near Venus for the whole month. And Mars is most certainly at opposition. Look how close it is to the anti-helion. So that was the night of the third and the morning of the fourth. So that was the quadrantids, the peak of this meteor shower. Let's talk about meteor showers. The quadrantids at 20 to 30 meteors per hour, that's not a real major shower. It is good to know that the moon, if you time it, the moon would be below the horizon when you go out to view. Closer to closer to dawn is best because then the meteors are hitting the atmosphere a little bit hotter than they are after dusk. You want to wait till it gets really dark to see them. But 20 to 30 meteors per hour, that's not really exciting to me because that, if you think about it, that's a meteor every 2 minutes, and you don't even know what part of the sky it's going to be in or whether it's bright uh, at at 30 meteors per hour, or once every 3 minutes on average for 20 meteors per hour. I prefer oh my gosh, I can't remember the name of the major meteor shower that occurs August 12th to 13th, but that meteor shower is the one to be excited about, followed by the mid-December, like December 15th, Geminids. Now, what I love about the Geminids is anybody can do the August 12th, 13th meteor shower, and I wish I could remember the name, and I'm not going to look it up with this time going by so fast. But but what I love about the Geminids, the reason they're my favorites is because you have to really prepare. It's very cold. It's a pretty decent sized shower, but if you're going to be out in the cold for 2 hours at a time, you got to come prepared. You got to have a sleeping bag, uh, maybe some food and some nice, thermos of coffee or something like that. You got to plan ahead for that. That's no joke. So we're now doing the day of the 5th, and let's talk about the next thing that's coming up. It's happening January 13th. We'll see the moon over here getting ever closer to Mars, which is on the opposite side of Jupiter. And you may say, wait a minute, if the moon is over here and Mars is on the other side of Jupiter, it hasn't even come into view yet. There it is. That moon better start getting moving to hit Mars. January 13th, they're going to hit, and that's 8 days away, right? How's that going to happen? Well, the moon at this time scale is actually booking. It's moving fast. And remember how it was south of the ecliptic plane? Now it's hitting the ecliptic plane. Notice that Mars isn't going to be moving that much and is north of the ecliptic plane. Um, it's actually going to be moving north of the ecliptic plane and hitting Mars, actually striking Mars, except for the fact that they're hundreds of millions of miles distant from one another. It will appear that Mars is striking, the smaller body is striking the surface of the moon, and it's especially nice to watch it in a telescope, because if you can imagine this green line as the field of view of a telescope, typically the moon will fill the entire for like a, a reasonable like my 128 millimeter reflective telescope, the moon will fill the entire thing. And then if you move a little off and you watch the limbs, you'll see Mars coming in like this. It's not nearly at this speed, then hitting the limb and disappearing, and then a half hour later appearing from the other side. Probably not straight on. It'll probably be like down here or something. But it's not like a major thing. Like if you're walking down the street, you're not going to go like, "Where's Mars?" It's not like that. Like if the moon disappeared, you might be like, "Whoa, what happened?" That would be a bad thing, actually. But if when Mars goes behind the moon, it's going to be these kind of things where people in the know are like, check it out. We got an occultation going on. An occultation is like basically like better than a conjunction. You can think of a solar eclipse as a conjunction of the sun and moon, but it only occurs when the sun by definition is always exactly on the ecliptic plane. It's the plane of the earth and sun that establishes the ecliptic plane. So by definition, we are the only two bodies that are always locked to the ecliptic plane, and then everything else is a little bit north or south and varies. Um, we're up to the seventh, and I'm already kind of hoarse and trying to fill time. Let me get some water because I can feel my hoarseness growing. Yeah, so I was talking about eclipses. A solar eclipse is basically an occultation of the moon with the sun. The sun is occulted by the moon. The moon occults the sun. So the same thing will be happening with Mars. It's just that unlike a solar eclipse, hardly anyone will notice that when that occurs tomorrow. I got to get out there down onto Whiskey Row or something and start interviewing people. Can you tell what's being eclipsed right now? No, you'd have to know what's going on. Maybe I'll even bring out my telescope and let people see it. That would be actually a cool thing. I did that once when a couple of years ago when Jupiter was at opposition. Once again, Jupiter would have been right here in the shadow of the sun, basically super bright and super close. When I say super close, it's still like, I don't know, 450 million miles away or whatever it is. I forget exactly how far Jupiter is, but through the telescope you could make out the Galilean moons and Jupiter and so on. And then, oh yes, maybe a year and a half ago, we had that epic, not epic, EPIC, but epic, EPOCH conjunction, sorry, that epic conjunction of Saturn and Jupiter, which happens every few centuries, maybe every 400 years, 450 years. They Saturn and Jupiter came not within 2 degrees of each other, which happens all the time, but so close together they could be within the same telescopic field of a typical telescope. Like a wide angle lens on a telescope is actually pretty narrow compared to like binoculars or something like that. So I have a photo of this through my telescope, but you could see Saturn and Jupiter within the same telescope field. From the naked eye, they would look pretty much like one point because one of them, probably Jupiter, was way brighter than Saturn. Yeah, I remember that actually. Yeah, Saturn was like below and left, and Jupiter was above and so it was below and right, and Jupiter was above and left, and it was a beautiful, beautiful thing. And I'm sorry if you missed it. You're gonna have to wait another few centuries for that to come around. But now that's an occultation. That's an occultation, but it's sorry, a conjunction. I mix my words all the time. That's a conjunction, but that's something that's so rare and so close. Of course, astronomers and folks like me, amateur astronomers, were very excited by that. And you can replay simulations or watch. There's all kinds of footage or photographs available from that epoch, even if you missed it on the particular nights that it occurred, because it evolved over the course of about a week. Um, we had that. So, okay, so let's see where we are. This is a now a night. The sun just set. It's the ninth. We have Venus here, and ooh, look how close Saturn is getting. Venus, Saturn. Here, the moon is very close to Jupiter. That should be Jupiter right there. And then we have Mars where? Mars is up there. Yeah, it's a little bit blocked by whatever that green label is labeling. We have the quadrantids, but they're done. The moon is basically now making its move on Mars. Look how much closer it is. And by the 13th, that's where that occultation is going to occur, lasting about a half an hour. Now, I'm going to need to do a little research. It'll be in the description of this video by the time I can do this. I'm not going to do this while making this video. I'm not going to pause it and trying to figure out the exact time because that's when the video becomes boring, if it's not already, and figure out the exact begin time and end time for that occultation for anyone really curious. But you will see Mars, you will notice that the Mars is going to always be further east than the moon, right? The moon is moving from the west to the east, creeping up on Mars. So here we're entering the night of the 10th. So let's watch the sequence of events. Sunset is roughly shortly after sunset, Mars will rise. And at that point, you'll always see Venus, Saturn. Then there's a big jump to where the moon and Jupiter are. So this is already like 2 days ago. So I'm talking like it's in the future and it's when it's in the past. And then here's Mars. Okay. So this was the night of the, oops, I hit my scroll wheel again. Did you notice the jump? Maybe that's just as well that we're a little closer in because everything interesting is really happening. We don't really care about the north and the south. That's where, stars and things are. And who cares about that? We're talking just about planetary stuff on the moon right here. So you can see these measurements along here on the ecliptic. They show where you are in each house. Like, I forget the names of the things. Isn't the 12th house Capricorn? I forget how the zodiac works exactly. I'm Cancer. I'm somewhere in the middle. But you get Cancer, Gemini, there in the middle. Capricorn and everything else is around here. The zodiac is determined by which house the sun is in. So that's these are numbered for simplicity, and I could turn on constellations very briefly. You would get an idea what the constellations are, and so on. But that's confusing, so let's turn it off. Or the constellation boundaries. Yeah, see that's another way of thinking of the boundaries between the constellations. All right, so this is now the night. Yep, this is the night of the 11th. We just saw Venus and followed by Saturn setting. So in the sky, we have Jupiter over here, the moon over here, Mars over here. Uranus is right there. Neptune is closer to the Venus Saturn system, but unless I zoom in big time, the labeling is such, unless it gets bright enough, meaning you're zoomed in enough, the labeling doesn't kick in. So apologies for not being able to show you exactly where Neptune is, but I'd have to be out of this 195-degree view. Oh, we're not even at 195 degrees. Let me get to 195 degrees. Oh, I guess that we don't need 195 degrees. For some reason, I thought it was important to get super fish-eyed, but it really isn't. This is cool because we can see the whole horizon this way, so you're not getting gypped. Now we're coming up on the night of the 12th. So this is the night before the occultation. Look how close the moon and Mars are now. It doesn't really look that close, but you have to. So the sun has set, Venus, Saturn. They are in conjunction, but they're not truly in conjunction because that's actually further than it looks, right? The whole sky is compressed into this green circle, so that's actually not really that close. The moon is definitely moving up quickly, even just in the course of the evening. You can see how much it's moving towards Mars. And there's Jupiter and there's Uranus. So the rhythm is such that once Mars is half off the screen, this is also the early morning hours. We're now at 4 a.m. Between 4 and 5 a.m. on the morning of the 13th. So this is the day that the occultation will occur. And you can see the moon and Mars are still spread. So this is the morning of the 13th. The occultation will occur when they next swing around, and it's the evening. So once again, Mercury rises first, followed by the Sun, followed by Venus, followed by Saturn. Then there's a long break before Jupiter rises. I honestly think that the misinformation of the six planets at a time, it's not so much. I'll read after the occultation. I'll read to you what NASA writes about it, which is very subtle pushing back. It's not like explicit pushing back on bad memes, which is what I'm going to do because I don't care. But they very subtly push back on bad memes by their language. Okay, so here we are that night. We can't see it because the moon is on top of Mars, but somewhere in here for a half hour, that's when that occultation can occur. And I can't tell you when with precision, other than I know it's after sunset and before sunrise on the 13th. Okay. And even now you can see they're separated. This is the morning of the 14th. So they've already separated. There's Mars, there's the moon, right? So it's got to be fairly early on in the evening after sunset when both of those will be in the east or east southeast sky. Now it's the morning of the 14th, and I can go and talk to you about the next thing coming up will be on the 17th to 18th, we will have the Venus Saturn conjunction. So these will be coming very close together. Venus, you can't see these during the day. This is the day, so you can't see them when they're here. You'll see them over here in the southwestern or west southwestern skies after sunset. Right after sunset and shortly after sunset and before they set, you'll see them. So here's sunset. You wait a little bit for it to get dark. Now you're looking for this pair here. This is the 14th, so this is still close together. There's an angular tool I can use, but I can't hit moving targets, so I can't tell you what that angular displacement is, and it's hard to estimate at such an extreme fisheye setting. There's Jupiter, there's the moon, and now it's really starting to move off of Mars. The moon will continue to move in a west to east pattern along the ecliptic. You can think of it again as the social butterfly that goes around opposite to the direction of well, it's following the direction of the Earth's rotation, but it appears to go in the opposite direction as the ecliptic is moving, if that makes sense. The moon is moving this way because we're spinning that way. That makes the sky move this way because we're spinning this way. Um, it's all about orientation. Get a bunch of marbles. You'll figure it out. Um, it's the 15th. Yeah, let me move on to what okay, here's what NASA says about it's a very brief thing that Mars says about Mars, what NASA says about Mars at opposition all month. Although, like I say, it's actually moving away from the anti-helion. See how now Mars is way over here and the anti-helion is over here? They used to be right on top of one another. So by this point, by about mid-month, actually Mars is starting to wane out of the opposition point at or near the aphelion. So here's what NASA says. All month, Mars at opposition, thumbs up. The red planet is directly opposite the sun, or nearly directly opposite the sun from Earth, and shines brightly all night. It's in the east as night falls, and in the southwest at dawn, right? So when you get all four planets visible, it's over here. Towards dawn, you can see it's moving towards the west northwest. Oh, they said southwest. Well, from our viewing location, I guess it changes where you are in the month. So this is now the day of the 16th. Let me read what they say about the other big thing. Really, the big thing. The big thing is all month, four planets will be visible. They don't say six because that's a little bit misleading considering you can't see Uranus and Neptune without a telescope, right? So four planets will be visible. In the first couple of hours after dark, you'll find Venus and Saturn in the southwest. So it's getting dark. Here's Venus and Saturn in the southwest, and they're about to be in conjunction. Jupiter high overhead. Here's Jupiter. And then Mars in the east. And then in parentheses, they say Uranus and Neptune are there too, but a telescope is needed to see them. So that's not exactly pushback against the memes. It's this next sentence, which is the pushback. Planets always appear along a line in the sky, and I'll add the name of that line is the ecliptic plane. Okay, it's not really a line because you can see it's kind of curved. Your arm is going to go up and down, but you're sweeping through the sky as if it were a line. Planets always, returning to NASA's quote, planets always appear along a line in the sky, so the alignment isn't special. What's less common is seeing four or five bright planets at once, which doesn't happen every year. Is it a planet parade? This isn't a technical term in astronomy, so call it what you wish. Well, I'm not going to call it a planet parade. I'm calling it a planet caravan because it's not hitting all at once. It's spread out. You know what I mean? Or a long, long, long caravan train. We got Mercury over here on the wrong side, so it's you can't see it during the day, so you have to wait till after Saturn and the sun sets, and then you get these four visible planets. So planet parade, planet procession, I don't know. It's not a string of pearls. I documented that, and I'll provide a link to it a few years ago. It wasn't really reported about that much. It didn't make any memes, but there was a very beautiful thing that was occurring all over, and I simulated it for Preskit skies a few years ago. Not this fast, because it all was only happening over a course of a few days or maybe a week. But oh, here's where the conjunction happened. Yeah, I talked over the conjunction. Yeah, the conjunction started yesterday and it's continuing today. Oops, I talked over it. Uh, Not going back and fixing that. I'm already on my third take. I'm not doing a fourth or inserting anything tough. Let's see what it looks like when they're not in conjunction. Yeah, see how close Saturn is now below the ecliptic. We're now coming up. This is during the day on the 18th. So right around here where they were lined up perfectly vertically, that was the conjunction where they were closest. But really for a day, about a day on each side, right? So this is the day of the 18th. They're going to be pretty close together, up to 2 degrees angular distance between them. So close so that they almost appear to be one object at this point. So at right here on the night of the 18th, you'll still see that conjunction with Saturn, the dimmer object, a little bit below the ecliptic, and Venus, the brighter object. Jupiter's straight up, and Mars is over here, and now look how far the moon has moved. So again, the moon is kind of like out of the picture at this point. It's not really part of the show, although very close to the end of the month is when the moon will approach its new moon phase, which to me is always more exciting than the full moon phase. And I'm not sure why. I think it's just these very thin crescents that are especially beautiful if you look at them in a telescope are just beautiful. Full moons are obvious. They're bright. The full moon occurs when the moon is at opposition to the Earth, by the way. And then in certain circumstances, when the moon passes actually literally into the anti-helion. The anti-helion is the technical name for the shadow of the Earth. Um, Basically, when the moon moves into the anti-helion, that's when you get a lunar eclipse. But that only occurs when the sun and the moon are lined up. The moon is wandering up and down the ecliptic by about 5 degrees plus, 5 degree minus every month. Every month it does that. The sun is always on the ecliptic, so there's only certain chances that the anti-helion and moon uh, align or the sun and the moon align. So it doesn't happen every month. It only happens on those months when you get the good alignment. So what's the next thing coming up? Oh, I'm sorry. The last scheduled event was January 17th to 18th. Now I can't really show it while I'm recording here, but I noticed that another bizarre anti-informational meme I spotted just today. I just did a search for like January 21st to 25th because I'm noticing there's a whole bunch of things which will say there's going to be this amazing conjunction occurring January 21st to 25th. Or no, it wasn't that. It was we're going to have all six planets lined up January 21st to 25th. No, remember again, that's utter crap. The planets are always aligned to the ecliptic plane, as you can see. It appears as a curve through the projection of the sky chart on the screen here, but you can trace your hand over in an arc, like a line. It's not really a line; it's an arc through the sky, and um, and they're specifically citing January 21st to 25th for absolutely no reason since the four planets will be visible literally every night. This is the night of the 20th. You can see one, two, three, four. Yep, they're all there. Notice how much Venus has moved beyond Saturn. Venus is the mover. Venus is now heading towards Jupiter. So in a couple of months, probably, Jupiter's going to come close sorry, Venus is going to come close to Jupiter. The moon is now heading even faster than Venus towards they all move this way, except when they're in retrograde, but I trust that none of them are. Oh, actually, Mars would be in retrograde right now because it's at opposition. Whenever an outer planet goes through opposition, by definition, it's in retrograde motion. I'm not going to attempt to explain the geometry behind retrograde. There's plenty of great lessons which showed that it's simply a matter of the fact that the Earth is swinging by faster than the outer planets, so the planet is appearing to move backwards in the sky from its normal motion, when actually the planet is totally doing what it normally does. It's just you have to think in terms of the planets orbiting the sun, and then it makes sense why the line between the Earth and Mars has now shifted direction from its normal traversal. We're up to the 21st, and I was thinking I was going to cut out the audio and just let the video run, but I do have more things to say. And you can see it at this, yeah, let's see, what haven't we talked about? I was talking about misinformation. Misinformation is largely unintentional and simply misinformed misinformation. But the problem is the algorithms scrape up all the muck, all the crap with the good stuff. And unfortunately, the good stuff, like this video, is super boring and never shared, right? That's just the truth of it. Scientific fact is not shared as much as stuff that has like emotional engagement. Ooh, they'll be all on a line. It'll be magic, or they put some kind of mystic nonsense to it. No. Um, Conjunctions happen all the time. Planets being aligned to the ecliptic plane is by definition the way the situation is. The important thing this month is you'll have four planets visible after sunset, shortly after sunset, every night. Like here, we're coming up on the night of the 22nd. Sunset is at about 1730. So at about 5:30 that night on January 22nd, local time, UTC minus 7 hours, We'll have sunset. You'll see Saturn and Venus in the sky. They're no longer in conjunction. Venus has now moved off. Jupiter's kind of straight up. Mars is over here. Um, and then there's nothing really else happening in the sky until Mercury rises. You see the moon rise right here. So moon comes up at about two. I didn't quite catch it. 2:30 in the morning. Antares is rising. That's a star. Notice how far south of the ecliptic now. Remember, the moon was north of the ecliptic to come in occultation with Mars. Now it's south of the ecliptic, and it's going to be at the ecliptic. I'm sorry, no, it's going to be south of the ecliptic. It's going to be passing below the sun by quite a bit. So actually, for you can predict because it's so far south of the ecliptic and it's going even further south. It's not going to be a super super thin crescent. It's going to be like a certain level of crescent, but basically it'll be very pretty because the moon will be passing under the sun with the crescent facing the sun, which would be really nice. Okay, now we're hitting. I might as well narrate the whole way through. We're hitting the night of the 23rd. Same thing. Now notice you will see Saturn set before Venus because they switched places. And Mars, I've lost. Oh, it's on the other side. It's over here. Jupiter's right there. Mars is right here. Jupiter looks like it might actually be pretty bright. And then Mars, and then a whole bunch of dead space on the ecliptic. You have constellations and such. I see a dipper, but who cares about those things? We're talking about moving things. We're talking about the planets. Moonrise. Moon is coming actually in conjunction with Antares. Look for that in late January. We'll watch those two probably on the night of the 25th. The moon and Antares will be in conjunction. Now, if you were to go, I should have back. I'm not going to back it up, but now you'll notice Mercury is starting to rise right before the sun because it's going around the backside of the sun. So even though it's going to be brighter because it's an inner planet, so when it's the outer planets are at occultation when they're near the Earth's shadow. The inner planets are brightest, not at occultation because there is no occultation. They never get near the Earth's shadow, if you think about it, because they're on the inside of Earth's orbit. Instead, it's when they go around the backside of the sun and they're full faced that they're brightest. So, unfortunately, despite the fact that Mercury will be brightest towards the end of the month, that also means it'll be closer to sunrise, and that makes it much harder to spot. So if you want to see Mercury at all, you have to go out right before dawn, right now, or else you're going to have to wait until it swings to the other side of the sun and it's on the side with the other planets. So next month I'll have to see, but um, let's see. Mars won't be moving that fast, but yeah, you'll get seven planets on one side of the sun. So the meme situation will be even worse, saying seven visible planets when at best you can only see five of them. But it is quite rare to get five planets in the sky at one time. That's the rarity. And I hope people will appreciate that. We're coming up on the night. Here's moonset during the day on the 25th. Now we're coming up at sunset shortly after 5 o'clock. Mercury sets first. Boom, followed by the sun. Boom, at about 5:40 or so, it looked like. Now again, we see Saturn now here, dimmer, but near Venus, Jupiter, and Mars. The moon is way off at this point, so the moon is not part of our night sky unless you want to catch it just before dawn. It's probably approaching Mercury at this point, getting closer to the sun. We also have Uranus thrown in there somewhere. Yeah, there's Uranus. And Neptune, again, is not labeled at this zoom setting because it's far too dim. Um, but Neptune would be roughly in the Saturn Venus uh, vicinity, I think, as I recall. So here's the moon. moon rising. Now you'll notice Mercury is a little bit south of the sun too. So what's going to start to happen is these will start to rise almost at the same time. And then it's just totally impossible to see Mercury. Forget about it. And of course here, this is during the day, so we're not seeing any of these planets at this point, though you'll see the moon during the day. That's all you'll see is the sun and the moon. And then you have to wait till sunset for anything interesting to happen. And guess what? It's not really that interesting. It's just the same show. It's going to be, oh, thank you, heater, for going off. I was wondering why I was getting annoyed by the background noise. Ah, much quieter. So after sunset, it's once again, you'll see Saturn, Venus, they switched, Uranus, Jupiter, Mars. And there's the anti-helion. Notice how far Mars is from the anti-helion. That it's still technically at opposition because it's like a wide berth they give for opposition. Actually, opposition may be technically the time that it is running in retrograde, which can be for like a month and a half or so, I think. So, or a good long time. So actually, maybe technically opposition means retrograde motion has started. So it doesn't have to be, it kind of like, it's weird what it does in the sky. It makes like a loop. It looks like one of those blue loops, blue things you put on your clothing to commemorate 911 or AIDS or whatever. Um, yeah. So the only really, we're almost up to the end of the month, and I'll go, you know what? I'm going to give you sky charts all the way through Groundhog Day. We're going to go up to February 2nd at midnight. Not for any reason other than to watch what Mercury is doing. But the moon is now getting closer to down here under the sun. Mercury's very close to that too, but it's going around the backside. The moon is obviously going to the front side of the sun. So the moon is now getting close to its new moon position. It'll be a thin crescent at this point, which to me, I don't know why, just aesthetically is way more pleasing to me and harder to spot than the full moon. Although I do get excited during full moons as well. Speaking of which, this is like my third take and it's coming up on 1:30 in the morning, so I'm gonna have to like let this compress before I do anything else and maybe take a nap. But yeah, here's the boring part, like waiting for Mars to set and the moon to rise. There's nothing in the sky. That's the downside, is the early mornings will have nothing in the sky. So where are the memes that say, look how rare it is? You can look up and there's no planets because they're all on the other side. Everyone focuses on where the planets are, not on where they're not. So we have the moon again coming into conjunction with Mercury, headed towards this spot right here. The Mercury is going behind the sun. The moon is coming in front of the sun. And again, this is during the day, so you can't see anything else on the sky besides the moon and the sun. Once they set, boom, boom, Mercury and the moon together, then the sun. Now you can see Saturn, Venus, Uranus, Jupiter, and Mars. So again, there's a good long time for a couple hours each night following sunset where you'll see four planets. And you'll even, as a result of knowing this video, you'll know which one. Just remember early on, it's Venus, Saturn, Jupiter, Mars. And then after the January 17th, 18th conjunction, Saturn and Venus switch roles or switch positions. And then it's going to be Saturn, then Venus, then Jupiter, then Mars, with Uranus and Neptune thrown in there as well, but I'm omitting them. Now we're at the 29th. Now, here's where it's interesting. So it looks like the new moon is going to occur on the 29th. That's when it passed closest to this below point of the sun, and it's already moved out of that. If I zoomed in, you would actually see the crescent, but I don't want to mess with my settings that much. I just want to let the time lapse run so that anybody can pause this video and make a sky chart just by hitting pause and trying to get close to whatever time of day you want down here. We're coming up on the night of the 29th. Now, this whole thing, Mercury, Sun, and Moon set. You have the same four planets. Wow, there was a whole rash of satellites that just hit, and a big one. That was probably the ISS flying by, the International Space Station. And yeah, as far as these planets are concerned, um, Venus, Saturn, Jupiter, and the Mars, not much going on. Really, the last timed event, aside from me observing, the Moon, Mercury, Sun system developing, oh, we missed there was that conjunction with Antares, which is a pretty bright star. The Moon coming into conjunction, but probably not occulting Antares, blocking it. Um, yeah, it's kind of like this time of the month after the 18th. There's that nightly thing where there's the four stars, the four planets being visible, but by now you've seen it 30 times or 15 times. Certainly in the simulation, you've seen it like 30 times. How boring, right? That's the other thing. A lot of these memes emphasize common events like it's some magic. Conjunctions happen all the time. It makes sense, right? As you watch them, things get close to one another because they're moving at different rates in your relative field of view, and things get overblown. We're never going to see this month an occultation of four stars. That's a misunderstanding of when somebody says there will be four visible stars in the sky. Why not bunch them up all close together and make a false meme out of it? How much more exciting is that? So again, this video is largely just informational to push back against all the memes that say this or that. And I'm less offended by the memes that say the six planets are in line as I am saying there will be six planets visible, because to me visible means you can see them. Yes, they're in your view, but it's stretching things a little bit to say they're visible. You won't be able to see those six planets. And in some of the graphics, they'll be the same size. They'll be drawn at the same size, like you can see Neptune. Again, like 1 in 20,000 people or something can barely make out Uranus. That's a confirmed thing. But nobody can see Neptune. Forget it. In fact, Neptune was only discovered because after they saw Uranus, what's his name? Herschel, the astronomer, uh, saw Uranus. They saw that Uranus's orbit was perturbed, and they didn't know why. Like every few years, it was a little off from where it should be, and then it would return. So they basically theorized there's got to be another planet. We'll call it Neptune, and it's got to be right there. So they theorized the planet, and they knew exactly where it was well before they could see it, which I think is very cool. And maybe that's what's happening with Planet Nine. Um, there's this hypothesized planet because they can see Pluto wobbling a little bit as well. I believe it's Pluto or maybe Neptune wobbling a little bit. So they think that out there's a pretty big thing, but it's very, very dark and hard to see. Well, welcome. We made it to February 1st at 5 in the morning. This is the boring part where there's nothing happening. Look how quickly close together the Mercury and Sun rise. So if you're going Mercury hunting, this is the wrong time of the month to do it. Um, if you're looking for dim, if you're looking for dim parts of the night to go watch things like meteor showers, maybe, um, then this is a good time because the moon is on the other side of the sun. So you see how the moon is really only bothering things during the day and is close to the sun. When you have the moon close to the sun, that means you have lots of night where there's no moon. So that makes for nice dark skies, right? That makes sense. So here we have sunset. Saturn is here. The moon and Venus are sort of in conjunction at this point. Uranus is right there. Jupiter is right there. Mars is right there. And now we're coming up on the more boring part, but we're coming up on Groundhog Day. So, thanks for watching this video if you lasted this far, and I hope you turn the sound off at some point and just watch the simulation. It shows just how dynamic at this time scale the motion of the planets are and how much detail is there, like Mars running in retrograde, the moon wobbling north and south of the ecliptic and its effects, and so on. And if you stuck through the whole hour or 50 minutes or whatever this video ends up being, probably about 50 minutes, then I apologize. I had fun recording it and I tried to make it as entertaining as possible. But these are the facts. You heard what NASA said, and what NASA said kind of lines up with what this free software says is going to happen. So I think this is pretty real. I think this, even though it's a simulation, I'm going to call it real. We're coming up now on midnight on Groundhog Day, and that's when I'd sign out. So this is Blind Man Bert of Science versus Universe and the Canamet Collective signing out, wishing you a happy, happy January of watching actual stuff. 4 visible planets. Maybe if you look down at the Earth, you can say you're seeing 5 visible planets, but you're definitely not going to see 6 visible planets ever. Well, unless you're one of those 20,000 people with the really good eyes.